Welcome. Today I would like to present to you a presentation on path pricing in a network. I'm going to give you a motivating problem. I'm going to discuss a novel formulation to this problem, and then I'm going to discuss the solution methodology and discuss the inferences from these problems, from these results, and some possible future research directions. Let me introduce myself. My name is Stephen Harrod. I went to school at a small New England college and got a degree in mechanical engineering, and then I had a co-op job at this factory in Hartford, Connecticut, where I wrote the instruction manuals for very large industrial machine tools. I then went to MIT and obtained a degree in transportation, which I applied in the trucking industry, and then I wrote some software for the trucking industry, which I sold under the name of Applied Arts, which was a company that I founded, and later on I was a database consultant in Kentucky. I received a fellowship to pursue my PhD at the University of Cincinnati, and my prior research was in the area of variate generation, random number generation from Poisson distributions. I looked at various algorithms and numerical methods. Why research railroads? Well, first of all, I've always been told that you should pick something you're genuinely interested in to maintain motivation in your dissertation. And you can see in the photo on the right there is myself. That's me working on the railroad, so to speak, many years ago. Another reason is railroad scheduling is really an unsolved problem. It's a great theory incubator. Many of the properties of a railroad schedule can be applied to other industrial problems, such as job shop scheduling, healthcare, say a hospital schedule, resource schedule. Any kind of problem where you have a shared resource and you have precedence paths. You have paths, user paths, that have very specific preceding relationships between the various resources they need to use. And the solution to this problem really unlocks many other operations research fields. Click on the black box to start this video right now. Thank you.
Last year, Norfolk Southern and its shipping partners took hundreds of thousands of freight loads off the highway. In fact, they've invested millions to convert even more traffic in the coming years. So it's easy to see how the economy won't be the only thing that benefits. Norfolk Southern, the future of transportation.
All right, we're back. I hope you enjoyed that little interlude. That commercial is very symbolic of the problem that I'm discussing in the railroad industry. It has many of the elements that are of interest to many different parties all tied in together. You have supply chain issues, you have transportation, you have highway congestion, you have the environment, and you have the very real marketing push on the part of many railroads, not just Norfolk Southern, to migrate more traffic from highway to rail. And by definition that means high-speed, on-time service on the railroads, which is a little bit of a challenge relative to the traditional kind of bulk commodity traffic. The graphic you're looking at now is a chart of intermodal traffic growth on Norfolk Southern in the last few years, and you can see that year over year there has been a continuing increase in intermodal traffic as a proportion of the general traffic, a very strong increase in intermodal. The next graphic shows you their carload traffic, their total carload traffic for all commodities, all modes over the last few years, and you can see year over year there's been really approximately a 10% growth each year, starting with the red 2004 and going 2005, 2006. And yet, unfortunately, at the same time, the average train speed is suffering. What you see here is the average speed of trains from origin to destination, including all the various stops and refuelings and switching and this kind of thing. And in the years 1999 to 2002, you can see that there was improvement, continuous improvement. Train speed was increasing. That implies a faster network, better throughput, better customer service, more efficient of resources. But then about 2002, 2003, it plateaus. and then it starts to decline, which demonstrates a deterioration in general operating principles on the railroad. And if we view all of these graphics simultaneously, we can really see the correlation between the increasing congestion, the increasing traffic on the railroads, and the increasing diversity of traffic with the growth of intermodal and the deterioration in system performance. And you can really see I've lined out how year by year these data points correlate with each other. So our motivating problem concerns railroad traffic, concerns their future marketing effort, concerns their desire to reach into new markets. So we have increasing traffic demand and traffic congestion. And we have at the same time this marketing push that will ultimately lead to more schedule complexity. We have more passenger trains going onto the system. Despite whatever you may have heard or believed, the reality is that we are operating many more passenger trains in the United States than we were 20 years ago, and the demand for more passenger train traffic is increasing in many metropolitan areas. We have priority freight and intermodal traffic as a sincere marketing effort on the railroads. And both of these lead to what are called more train passes. These are fast trains overtaking slow trains. And this is a different kind of dispatching challenge than the railroads have been used to dealing with in the last 30 or 40 years. The bigger problem on top of this is that we now have conflicts between marketing groups within the railroads. So for example, you might have a commodities marketing group and you might have an intermodal marketing group, and they might actually be in conflict with each other because they have different pricing strategies, different promises they have to make to their customers, and they have different demands on the railroad's infrastructure. Secondly, there are going to be separate operators sometimes sharing these tracks. This can occur either as a part of traditional trackage rights where two railroads have already agreed to share access to track. Amtrak is a big operator on shared trackage. Amtrak typically operates as a tenant on many freight railroad systems. And then we have something new called open access, which is being aggressively pursued by some shipper advocacy groups. Open access would mean that a shipper would be allowed to purchase their own train and then rent time on the railroad network. And this is a very touchy political subject because it raises all kinds of questions about who ultimately has dispatch authority and how you go about actually pricing that track access. So all of this together leads to very more frequent dispatch disputes, and these disputes are difficult to settle because we really do not have mutually agreed methods of valuing this network capacity, largely because, as I mentioned earlier, this is an unsolved problem. We do not have agreed optimal methods for valuing and pricing track capacity and setting train schedules. Typical dispute, just to give you another example, would be Amtrak versus CSX this last year. Amtrak has a corridor between Washington, D.C. and Miami called the Florida Corridor. They run long-distance trains on this route. The trackage is CSX track, so Amtrak is a tenant on CSX. Now, in June of last year, 29% of their trips on this route were greater than 4 hours late. And they had a meeting to discuss this problem, and CSX took the position that the Amtrak schedules were really infeasible and that it was really necessary for Amtrak to reduce the speed of their trains. And now Amtrak took a much stronger opposing position. Amtrak has the position that their legislation, their enabling law that wrote Amtrak into existence in 1970, does in fact give them federal right to speed and priority dispatch on the freight railroad network. It is actually written into the federal books that Amtrak does have priority dispatch rights to the freight railroad network. Another dispute, another challenge is the lost market, the United Parcel Service. In this example, Federal Express currently runs their packages coast to coast by road. They use team-driven tractor